By adding IoT sensors, we can provide real-time data and custom alerting to prevent claims from occurring. We also apply robust predictive models to the heaps of historical sensor data to predict claims based on geography, even by customer. This platform reduces costs for insurers and their customers, paving the way for lower premiums and increased customer loyalty. The first app in our use case is a real-time dashboard for service providers. The insurance company contracts out a service provider to monitor and maintain the health of 4 cold storage warehouses in South Florida. Think of this as a live status screen in the service provider's operations center. Each warehouse has many refrigerated rooms storing food, and each room is equipped with 3 sensors: one temperature sensor, one humidity sensor, and one open and close sensor for the entry door. This list on the left gives a status summary for each room, including how recently the sensors have checked in. I have the temperature sensor for room 3000 in an ice bucket on my desk to provide an interactive demo. I'm going to raise the temperature probe out of the ice to simulate a temperature increase in room 3000. Our app uses WebSockets to allow this dashboard to refresh individual data elements without requiring any user interaction. This sensor's heartbeat is set to 1-minute intervals, so let's have a look around while we watch the temperature rise in room 3000. You'll notice that when I clicked on the room in the list, it shows this graphical view of current and historical sensor data. The speedometers on the left show some predefined thresholds for green, orange, and red alerts along with the current value. The line graphs on the right show trends over the past few minutes, hours, and days. The bottom bar graph is a visual representation of how many times the room door was opened per hour within the last day. Remember that our use case is to show how we can use IoT sensors to catch anomalies and prevent claims before they happen. Because the refrigerated units are storing food, there are multiple scenarios that might result in a food spoilage claim. One might be if the temperature in the room crosses the threshold into orange and remains there for more than 2 hours. Another might be if the temperature ever crosses the threshold into the red. We can see from the current line graph that the temperature has increased in room 3000. We have configured alert notifications so that the policyholder first gets notified via SMS and email when the temperature increase first crosses the threshold into orange. Maybe the consumer left the door open, which they can likely resolve. If the temperature remains orange for more than 15 minutes, we push a message or work order to the service provider queue, which dispatches someone to investigate and proactively resolve the issue. We've configured the system such that when the temperature in room 3000 crosses the threshold into red, we leverage our integration with an insurance system to automate initial claim creation. As you can see, this is a mocked-up Duck Creek claim that was automatically created based on a temperature threshold critical alert in room 3000. The second part of our use case is to show how the insurance company can leverage all of the sensor data to generate business value. We have a handful of predictive scenario dashboards to slice the sensor data in various ways. The first shows sensor performance by manufacturer. Who are the sensor manufacturers that the insurance company should work with? The second screen is basically a zoomed out view of the service provider dashboard to show the current health of the entire system. The next dashboard helps identify events and incidents. The bottom left shows that G1 and G2 are correlated, but having issues because one is alerting when the other one isn't. The green spikes indicate the anomalies between the two sensors. The bottom right graph even overlays average outside temperature over average sensor temperature. The fourth screen shows customer segmentation by sensor data. This helps insurance companies enable premium discounts based on lower claim probability. Clicking Robert Christopher refreshes the specific sensor downtime and the probability of claim and premium discount below. Conversely, Ralph Keith has no incidents, which raises the premium discount because of the lower probability of claim. The fifth screen showcases loss ratio by location and by number of claims, both broken down by month. Who are the customers who are living in the location with the maximum number of claims? All of these dashboards roll up to the final screen of Claim Prediction Insights. Using historical data, we've created predictive models to predict the number of claims, total amount of those claims, and the number of claims avoided.